SpaceX stands out in the aerospace industry for its willingness to push boundaries and pursue ideas that others might dismiss as impossible. What makes the company truly remarkable is its ability to take these bold concepts and turn them into reality. One of the best examples of this is the Raptor engine, the core of the Starship rocket, designed to change space travel forever. The Raptor is not just another rocket engine, it is a complete reinvention of how a rocket engine can operate. To understand its significance, it's important to first look at SpaceX's early engine, the Merlin. During the development of Falcon 1, multiple versions of the Merlin engine were introduced. The Merlin 1C powered the first successful Falcon 1 launch and was later used in the first 5 flights of the Falcon 9. Today, the Merlin 1D powers all Falcon 9 and Falcon Heavy rockets. The Merlin engine was born out of SpaceX's chaotic early years. In the 2000s, the idea of a private company entering the orbital launch industry was unheard of. No one believed in their success, and no one was willing to invest. Elon Musk decided to fund the company himself with his fortune from selling PayPal, but despite his wealth, the company was burning through money as fast as it was burning rocket fuel. Because of this, Musk insisted on a simple and cost-effective engine design. To understand why Raptor is so revolutionary, it helps to briefly go over how rocket engines work. A rocket has 2 main propellant tanks, one for oxygen and one for fuel. Oxygen is crucial for combustion, just like blowing air onto a fire makes the flames burn hotter. But to use oxygen as rocket propellant, it has to be converted into a liquid by cooling it to cryogenic temperatures, below its boiling point of 183 degrees Celsius or 297 degrees Celsius. On the fuel side, the Merlin engine runs on RP1, a refined form of kerosene that is inexpensive, widely available, and stays liquid at room temperature. When the rocket ignites, 2 high-pressure pumps move both oxygen and fuel into the combustion chamber. There, they mix, ignite, and release an enormous amount of energy, causing the gases to expand and generate immense pressure. This reaction pushes hot exhaust gases through a narrow passage called the throat, much like how pursing your lips while blowing air creates high pressure. The gases then expand through the nozzle, accelerating as they move toward the exit. The bigger the difference in size between the throat and the nozzle's end, the faster the gases accelerate, producing more thrust. This process follows Newton's third law. Every action has an equal and opposite reaction. The Merlin engine's fuel and oxygen pumps are powered by a gas generator, essentially a small rocket engine with its own combustion chamber. Instead of firing downward like the main engine, it directs its thrust into a turbine, which spins the main pumps. After the gas has done its job, it's expelled through an exhaust pipe. This system, known as an open-cycle gas generator, dates back to 1944 and the German V2 rocket. When Elon Musk set out to build the simplest and cheapest rocket engine possible, this was the most practical approach. The Merlin engine has been a massive success and continues to play a key role in SpaceX's operations. However, when it came time to design Starship, a new kind of engine was needed. Musk challenged his engineers to build the most advanced rocket engine ever created, achieve the highest thrust-to-weight ratio, and use a new type of fuel never before utilized in rocket engines. Instead of relying on traditional designs, they had to start from scratch. One of the biggest changes was switching from kerosene to methane. Just like oxygen, methane must be liquefied at cryogenic temperatures to be used as rocket fuel, which adds complexity, but the benefits make it worth the effort. Kerosene is a long-chain hydrocarbon, making it difficult to fully combust. It leaves behind solid carbon residue, or soot, which builds up inside the engine. While this isn't a problem for disposable rockets, it's a major issue for reusable engines like the Merlin, which need to be cleaned between launches. Methane, on the other hand, is mostly hydrogen, with only 1 carbon atom per 4 hydrogen atoms. This makes it much easier to burn completely, leaving no residue behind. It's the same reason natural gas, which is primarily methane, can burn in home furnaces and stoves without creating buildup. This makes methane the ideal choice for a fully reusable rocket engine. The Raptor engine is more than just a fuel upgrade. It features a fundamentally different internal system. While most engines use a single gas generator, Raptor uses a full-flow staged combustion cycle, an incredibly complex system. Both the methane and oxygen pass through separate preburners, where they are partially combusted and turned into superheated gas. These gases then spin turbines, which power fuel pumps that send the now high-pressure gas into the main combustion chamber. Unlike traditional engines, every bit of propellant passes through a preburner first, making Raptor far more efficient. There's a major challenge to starting this engine. Since the pump feeds fuel to the turbine and the turbine spins the pump, how does the cycle start? SpaceX solves this by using external equipment on the launch mount to spin up the turbines before ignition. This is why Starship's launch pad is known as Stage 0. It plays a critical role in getting the rocket off the ground. Raptor is also a closed-cycle engine, unlike Merlin, which expels some gases as waste. In Raptor, all the pressure from the gas generators is retained inside the system, which means extremely high operating pressures. If this was attempted with kerosene, soot would build up and destroy the engine. Because oxygen and methane enter the combustion chamber as gases rather than liquids, Raptor achieves an extremely high combustion efficiency. Elon Musk has claimed that Raptor's efficiency is over 99%, the highest possible under the laws of physics. He even joked that only God himself could mix molecules better than the Raptor combustion chamber. Despite being compact, Raptor produces an enormous amount of thrust. Raptor V2 generates 230 metric tons of thrust at sea level, significantly more than the RS-25, which powered the space shuttle and now the SLS moon rocket, producing only 190 metric tons. At the same time, Raptor weighs just 1,600 kilograms, while the RS-25 weighs nearly 3,200 kilograms. The secret to Raptor's performance is its high combustion chamber pressure. Raptor operates at 300 bar, or about 4,351 psi, compared to Merlin's 100 bar. More pressure means more thrust. Elon Musk has made it clear that the next step in Raptor's evolution is simplification. His design philosophy is based on the idea that the best part is no part. His approach involves questioning assumptions, removing unnecessary components, optimizing the design, accelerating production, and automating the process. The transition from Raptor 1 to Raptor 2 already reflects this approach. The newer engine has significantly fewer visible components, integrating smaller pipes into larger conduits and replacing bolted flanges with solid welds. These refinements even allow SpaceX to remove protective heat shields, making the engine lighter and more efficient. Simplification makes Raptor cheaper to produce and easier to manufacture in large numbers, critical for sustainable space travel. Many wonder why SpaceX needs so many engines if Starship is fully reusable. The answer lies in Musk's long-term vision. He isn't just designing one rocket, he's building an entire fleet. His ultimate goal is to make space travel as common as commercial air travel today. He envisions a fleet of at least 1,000 Starships operating constantly, ferrying cargo and passengers between Earth, Mars, and the Moon, and even enabling rapid point-to-point travel on Earth. Starship has the potential to become one of the most significant vehicles in human history, just like the first sailing ships that crossed oceans and connected civilizations. But instead of connecting continents, Starship will connect planets, and one day, perhaps even the entire solar system.